Okay, for Algebra 7.2 notes, we are multiplying powers with the same base. So the essential understanding is that you can use a property of exponents to multiply powers with the same base. So we've talked a little bit about bases, but bases are basically the whole number. It's whatever kind of, I'm just going to say, touches the ground. So 3 is the base. If they have the same base, you can take their exponents and do a little trick with it. So if you have 3 to the 4th power, that means 3 times 3 times 3 times 3 times 3 squared, which means 3 times 3. That is a total of 1, 2, 3, 4, 5, 6 threes, which means the answer is 3 to the 6th power. So this is called expanded notation. I'm expanding 3 to the 4th and I'm expanding 3 to the 2nd. But if you do that, it shows that there are 6 of them. And so a much easier, quicker way to go from here to here is just by adding the exponents. So 3 to the 4th times 3 to the 2nd is 3 to the 6th, because 4 plus 2 is 6. So, and that's kind of what they have it here too. So the essential understanding is it doesn't matter what the base is. If it's the same, you can take the exponents, and when you're multiplying, you can take the exponents and just add them. So a to the m times a to the n would be a to the whatever m plus n equals, or you can just leave it, m plus n. Okay, so let's try that with a few of these. That is super blurry. Again, sorry. 12 to the 4th is the same base as 12. This is to the 3rd. So if it's 4 of these and 3 of these, that is a grand total of 7 12s. So 12 to the 7th power. Negative 5 to the negative 2 times negative 5 to the 7th power would be negative 5. Let's go ahead and keep it in parentheses if that's how they have it. To the negative 2 plus 7. Negative 2 plus 7 is 5. Okay, let's go ahead and pause the video and try these 3 got it's on your own. All right, checking your work. 8 is the base, so 8 is going to be the answer for the base. And 3 plus 6 is 9, so 8 to the 9th power. 0.5 is the base, so 0.5 is going to stay the base, and if they keep it in parentheses, we're going to keep it in parentheses too. Negative 3 plus negative 8 is negative 11. Okay, and then all 3 of these are the same base. We've got a 9 and a 9 and a 9, so that means my answer is going to be 9, and I can add all of the exponents. Negative 3 plus 2 is negative 1, plus 6 is positive 5. 9 to the 5th power. Okay, this is when bases are not the same. So when bases are not the same, you're just going to go ahead, and if the dot is multiply, we're just going to multiply. So for right now, I really want you to look at only the coefficients. That would be the number in front of the variable. So we've got a 4 here and a 9 here. I know it's hard to cover them up, but pretend the z's are not there at all. The z to the 5th, invisible. Z to the negative 12, invisible. We just have a 4 times a 9. 4 times 9 is 36. Z and z, if they are the same base, just like we did up here, if they were the same base, you can add the exponents. So z's are the same bases, so we're going to keep it z, and we're going to add the 5 and the negative 12. 5 plus negative 12, is negative 7. So z to the negative 7. Now, I'm going to incorporate a skill we learned in 7.1. You can't have a negative exponent. It's going to need to flip to the bottom under whatever was there, or a 1 if there was nothing there, and then it would become positive. So even though for today I would probably take this, when you do your homework, I think they're going to make you show that yesterday's skill, which was taking a negative and moving it to the denominator and then it becomes positive, is a skill that you can still remember how to do. So this is the total simplified answer. Because z had a negative exponent, it needs to flip to the bottom and become positive. Okay, Pretend there's no A, it's invisible, no B, it's invisible, no A, it's invisible. Only look at the coefficients, the 2, the 9, and the 3. Let's multiply those. 2 times 9 times 3. 2 times 9 times 3 equals 54. So this is going to be 54. Now remember, we're going alphabetical with our variables. So we've got an A to the, that's a hidden invisible 1. And we've got an A squared. So 1 plus 2 is 3. So this is going to be A to the 3rd. And now we don't have B to add anything to, so we're just going to leave it, B to the 4th. And that's all. There's no negative exponents, so we can just leave it exactly how that is. All right, if you guys think you got it, go ahead and push pause and try the next 3. Okay, if you're ready to go over it with me, let's try. We are going to just ignore the x's to begin with and look at only the coefficients. We've got a 5 and a times 3. 5 times 3 is 15. Now we'll look at the x's. Since they are the same base, we can add their exponents. And remember, if there's nothing, it wouldn't be there at all if it was 0. So since it's there, we know it's there with a hidden invisible 1. So we are going to do x to the power of 4 plus 9 plus 1, which is 14. All right, on B, don't look at the variables yet. Only look at the coefficients. We're starting with negative 4 times 7 times 2. Negative 4 times 7 times 2. I'm going to use my calculator. Negative 4 times 7 times 2 is negative 56. Now I'm going to look at the variables, and we're going to go alphabetically. So we're going to do c to the 3rd and c to the negative 2nd. So remember, you can add those exponents. 3 plus negative 2 is 1. So c to the 1, you can leave it invisible. If it's a 1, you can leave it invisible. And then d squared is the only one that's a d. So d squared is just going to stay d squared. There's no negative exponents. Remember, if it's a negative coefficient, that's fine. But it's when it's a negative exponent that we're going to have to flip it to the opposite location. All right, letter C, the only coefficient I see is this 12. So we're going to put 12. And now I'm going to look at variables, and I'm going to go alphabetically. J comes before K. So let's do the J's. We've got a J to the 2nd and a J to the, that would be a hidden invisible 1. So 2 plus 1 is 3. So J cubed. And then K to the negative 2 is a problem. You can't have negative exponents, so this whole term is going to have to flip to the denominator. We don't have a denominator, so we're going to have to make one. So 12j to the 3rd gets to stay up top in the numerator. There's nothing wrong with it, but flip to the bottom now is going to be the K to, remember, once you flip it to the bottom, it's no longer negative, so it's a positive 2. And now it's done. Okay, I know that sometimes you learn scientific notation in science class, but it's also a math skill that we learn in pre-algebra, so you're supposed to know how to do this. So let's review, and if this is brand new to you, then you need to learn it now. For a number to be in scientific notation, it must be in the form of a number times 10 to the power of an exponent, like 2 times 10 to the 4th, like 9 times 10 to the 5th. It's always a number times a 10 to the exponent. Okay, here's what's important. The first number, that would be this one, that would be this one, that would be this one. That first number has to be bigger than 1. Even if it's 1.1, that's fine. It has to be bigger than 1, and it has to be smaller than 10. So if you reach a 9.9, that's okay. But if it's a 10 point something, it's too big. So the way that a lot of kids remember that is the number in front of the decimal has to only be one place value. So if it becomes 10 point something, that would be 2 place values, and that's too big. So between 1 and 10, if it's not between 1 and 10, you have to move the decimal, which also ends up increasing or decreasing the exponent value. Okay, that's a lot of words. Let's put it into motion. So we want to start by multiplying these coefficients, these numbers out front. So 2 times 9. which is 18. If the bases are the same, you can add their exponents. So this is going to be a times 10 to the 4 plus 5, which is 9. The problem with this, it's not technically scientific notation because 18 is much larger than 10. So we are going to have to drop a decimal at the end and move it backwards one place. And so this 18 becomes a 1.8. Now it's between 1 and 10, which is fine. But if you make this number smaller, it's going to bump this exponent larger. So it is now no longer 18 times 10 to the 9th. We are representing that same number as a little bit smaller, which means we are going to bump this number up. So this would be times 10 to the power of 10. So anytime you make this number smaller, your exponent gets bigger. If you make this number bigger, let's say it was 0.2, well, your number has to be between 1 and 10. So I would need to move this one to the right, which would make this exponent smaller. Okay, it just is going to take some practice. So again, we start by multiplying the numbers in front, which is 9 times 3, which is 27. That's going to be a problem because it's not between 1 and 10, but let's keep going. Times 10 to the power of, if the bases are the same, you can add exponents. 7 plus negative 16. 7 plus negative 16 is negative 9. So negative 9. All right, remember, it's not scientific notation because 27 is way too big. So I'm going to drop a decimal and move it back one place to make this number smaller. So now it's 2.7, and therefore we need to make this exponent one number larger. So times 10 to the, instead of negative 9th, one number larger would be the negative 8th, closer to 0. All right, if we move the decimal 2 places, we would move this up 2 exponent amounts. All right, let's push pause and try the got it on your own and see if you can do this. All right, the first problem I see is this number is not in scientific notation. That's too small. But that's all right, because all we're doing is multiplying it anyway. So we're going to take 0.2 and multiply it times 4. 0.2 times 4 equals 0.8. That's a problem. Times 10 to the power of, we can add these exponents. So 5 plus negative 12 is negative 7. All right, we need to make this number bigger because 0.8 is not between 1 and 10. So I'm going to move the decimal to make it bigger, which means I need to make my exponent 1 smaller. So if I move it, it's just going to be 8, or 8.0, which is the same thing as 8, times 10 to the, making this smaller goes further away from 0, so that would be to the negative 8th power. All right, let's look at the next page of notes. So go ahead and go to the back. All right, these are rational exponents, which I'm going to explain how to do it, but your calculator will also do this for you, so I'm probably going to recommend just having a calculator nearby. If it's 81 to the 1/4 power, basically what we're saying is how many fourths, this is the answer, first of all. 81 to the 1/4 power is 3, because we are finding the number that when you multiply it times itself, which is 3 times 3 times 3 times 3, it gives you 81. And do you know how many times it gave it to you? 4 times. And that has to do with the 1/4. So basically what you're trying to do is you're trying to come up with a number that when you multiply it times itself 4 times, you get 16. So a number times itself, times itself, times itself, that would be 16. It's not 4, because 4 times 4 is already 16. You need a number, 4 of them, that would be something times itself, times itself, times itself, that would be 16. So I believe that would be 2. Let's make sure that 2 times 2 times 2 times 2 is 16. 2 times 2 times, yes. So the answer is just 2. Now, if you don't want to come up with that in your head, what number times itself 4 times is 16, you can also just take it and put it in your calculator. So 16 to the 1/4 power is 16 to the, remember I taught you this little caret key is to the power of, and then I have this ABC button, which is a fraction, and so if it's to the 1/4, I'm going to do 1 ABC4, and that's going to give me that, yep, the answer is 2. Okay, so one more time how I do this. I need 3 of them this time. Over here it was 4 of them, that's why there were 4 2's. So I need a number times itself 3 times, that would equal 27. What number times itself again is 27? I believe it's 3. 3 times 3 is 9. 9 times 3 is 27. So I think this answer is 3. But again, if you don't want to sit here and go, okay, I know I need 3 of them because it's into thirds, and I don't know what number times itself is 27, let's just put it in my calculator. 27 to the power of 1/3, which would be 1 ABC 3, equals 3. Yep, we got it right. Okay, and then last one is kind of easy. You can probably do this one in your head because I only need 2 numbers. I need a number times itself that equals 64. So that's going to be 8. 8 times 8 is 64, but again, just one more time in your calculator to make sure that you know how to do it. 64 to the power of 1 ABC2, because it's 1/2, equals 8. Okay, so what happens if it's just not a 1 on the top? If the numerator, see this was 1/4, 1/3, 1/2. What happens if it's 3/2? So if it's 3/2, you need to break it down into 3 of the 1/2's. So if there's 3 halves, I need 1/2 3 times. And we just solved this problem and got 8. 64 to the 1/2 power is 8. So it's 8 times 8 times another 8, which is 512. So I can work this out, but I'm also going to just put it in my calculator because honestly, the working it out part is showing you how to do it, why it is the answer it is, but the calculator is so much faster. So if I have 25 to the 3 halves, that's the same thing as 25 to the 1/2, 25 to the 1/2, and another 25 to the 1/2. Now, there are 3 of them because the top number, the numerator, is 3. I know that a number times itself that equals 25, and I need 2 of them, is 5. So it is 5 times 5. This one is also 5 times 5. This one is also 5 times 5. So I'm going to have 25 times 25 times 25, which is going to be a really big number. So that's why I think it's a really important thing to know how to just put it in your calculator. So I'm going to start back from the beginning and put 25 to the 3/2 in my calculator. 25 to the 3ABC2, it's 125. So that is 125. So this would be, because we only need it 5 times. I'm sorry. 5 times 5 is the answer, so it's 5. 5, sorry, we didn't write 8 more than once. 5, 5, and 5. 5 times 5 is 25, times 5 is 125. Good thing I used my calculator. Okay, let's use your calculator on the other 2 as well. So 27 to the power of 2/3 this time, 2 ABC3, they flip-flopped it on us, is 9. And you can work this out or you can just practice using your calculator. And then 16 to the 3/4 power, 16 to the power of 3 ABC4 is 8. Okay. This bottom section, I just added on here because there's several on your homework today that look like this, and I don't feel like we had a lot of practice. So I'm going to flip through these super quick, but if you really think you have it, you might fast forward and just like check one of them or check one of them down here and make sure you know what you're doing. Otherwise, your notes for today can be done. Okay, for answers, here we go. If the bases are the same, you add their exponents. So 7 to the 4 plus 3 is 7th power. Bases are the same, so we're going to leave the base the same. 2 plus 7 plus 0 is 9. -6 in parentheses stays -6, and we're going to add exponents. 12 plus 5 plus 2 is, oh, what is that, 17, 18, 19? Yeah, I think that's right. Sorry, now my computer went to sleep. The one below, the base is 5. We're going to add -2 plus -4, which is -6, plus 8 is 2. All right, the base is 9, 9, 9, so we're going to leave it 9. 6 plus -4 is 2, plus -2. Ooh, look at this one. 2 plus -2 is 0. Anything to the 0 power is 1. It's not 9 to the 1, it's just the whole thing is 1. Okay, and this last one, -8 is in parentheses, so let's leave it in parentheses. 5 plus -5 is once again 0. Anything to the 0 power is 1. Okay, these bottom ones, if the base is the same, you can add the exponents. So m to the 3rd times m to the 4th is m to the 7th. I'm going to move down here, x to the 5th and x to the -6th. Because the x's are the same, you can add their exponents. 5 plus -6 is -1. That's a problem. Y squared, I'm going to move on to y, times y to the hidden invisible 1 is y to the 3rd. So y is fine. That's a positive exponent. But the -1 exponent is going to have to flip to the bottom in the denominator. So our final answer is going to be y to the 3rd over x to the, now it's a positive 1. And you don't even need to put it because it can stay hidden invisible. Up to 15, the coefficient 5 is going to be multiplied by a hidden invisible 1, or else you can look at it as we're just leaving it 5. The c's are the same base, so we can add their exponents. 4 plus 6 is 10. 5c to the 10th. On the bottom, remember, if the coefficients are all different, you're going to pretend like you don't see the x to the 5th or the y to the 6th or the x squared for a minute. We're just going to look at the coefficients first and multiply those. So 5 times 3 times 3. 5 times 3 times 3 is 45. And then we're going to go alphabetically. X comes before y. So x, 5 here and 2 more here is total of 7. Then we can stick our y on there and it's the 6th. And that's all we've got. So that's it. Last two. Look at our coefficients first. We're going to multiply the 4 times 2, which is 8. T's are the same base, so we're going to leave it t, and our adding -5 plus -3 is -8, but that's a problem. You can't have a term that's got a negative exponent. 8 is fine. 8 can stay up top, but to the bottom is going to go t, and now it's a positive power of 8 once it has flipped. All right, last one. I'm looking for just coefficients. This is a negative hidden invisible 1 coefficient. So -1 times 4 times 12 times 5. Yuck, I'm using my calculator. -1 times 4 times 12 times 5 equals -240. Now let's look at exponents. M, R, I think M comes before R alphabetically, so let's do our M's first. You have 2, and then you have another hidden invisible 1 over here for a grand total of 3. Then we move on to R. We have 3 here and -4. 3 plus -4 is -1. That's a problem. This one's going to have to go. So all of this can stay in the numerator, but this is going to flip to the denominator. So our final answer is -240 m to the 3rd over r to the, now it's a positive 1, but you can just leave it hidden and invisible.